Okay, before we start our class today, let's have first a prayer. Okay, Joanne, please lead a prayer. Amen. Okay. Now, let's check your attendance. Okay. Who isn't here today? Okay. Shai Reyes, May Flor, Gisabel, Jane, Johan Mabolo. Okay. I am glad to see all of your handsome and pretty faces. Okay, now, before we start our class discussion, what should the students do when the teacher is speaking or discussing? Yes, very good. All you need to do is listening. If you have to ask a question or you have any clarification, what should you do? Yes, very good. Just raise your right hand and ask. Okay. What else? Yes, very good. Keep your unnecessary things. Don't interrupt when someone is speaking. Okay, that's good. Okay, now let's have a recap. Last meeting we talked about Newton's law of motion. Yes. To check if you still remember our previous lesson, what is the first law of motion? Juan, yes. Okay. Very good. The first law of motion is inertia. Inertia is an object at rest and an object in motion remains in motion at constant speed and straight line unless act by an unbalanced force. Very good, Juan. What is the second law? Yes, Gisabel. Very good. Clap your hands here. Okay, the second law of motion is law of acceleration. Acceleration is an object is directly proportional to the magnitude of the net force acting on it and inversely proportional to its mass. Very good. What else? Yes, Shermaine. Very good. The last law of motion is all about action-reaction. For every action, there's an equal and opposite reaction. Okay. Okay, let's proceed to our topic. You have your first activity. Okay, gives me. Okay? As you can see in this picture, try to guess and analyze this picture to get the correct answer. If you wish to answer, just raise your right hand. Okay? Okay. What is the answer? It is work. Very good. It is work. Okay. Now, based on your activity, what comes in your mind when you heard the word work? Some say that work is all about job, but in physics, what is work? Okay, yes, Johan. Very good. In physics, work is an abstract idea related to every energy. When work is done, it is accompanied by a change in energy. When work is done by an object, it loses energy. Okay? Let me present to you our class objectives. Our class objectives. Our class objectives. First, identify the one doing the work and on each object is work done. The second is calculate the work done by force. And the third is relate the real life situation. Okay? Now, you have another activity. Guess the picture if it is work is done or no work is done. Okay, you have few minutes to answer. Okay, time is up. As you can see in this picture, is it work is done or no work is done? Yes, very good. The number one answer is work is done. The second one is no work is done. The third is yes, very good. No work is done. Because in the second number and the third number is the things is not moving. There's no displacement from one another to one another space. Okay. How to calculate the work? Let me present to you. Calculating work. Work is done when force F applied to the object causes the object to have displacement D. In the same direction as the force applied, the symbol of work is a capital W. The work is done by a force can be calculated as, this is the formula, W equal FD, unit of work equal unit of force times unit of displacement. Unit of work equal Nm, unit of work Nm or joules or G. Okay, now let's have a activity. An object is horizontal drag across the surface by a 100 N force acting parallel to the surface. Find out the force in moving the object through a distance 8 meters. So, you have a few minutes to answer. Okay, time is up. Since F and D are the same direction, theta equals 0. Theta is the angle of the force to the direction of movement. Therefore, okay, what is the answer? Yes, very good. 800 joules. W equal FD. W equal 800 times 8 times cos theta equal W is equal 100 800 joules since cos 0 is equal 1. So the answer is W 800 joules. Okay. Now to check if you understand our lesson today, let's have another problem. Suppose woman is pushing a grocery cart with a 500 Newton force along the 7-meter aisles. How much work is done in pushing the cart from one aisle to another? Okay, you have few minutes to answer. Okay, time is up. What is the answer? It is 3,500 joules. Okay, the answer is W W equal 500 newtons times 7 meters equal 3,500 mm, or we can convert it to W equal 3,500 joules. That is the correct answer. Okay. So, what is the formula of work? Yes, Johan. Yes. The formula of work is W equal FD, unit of work equal unit of force times the unit of displacement equal unit of work equal Nm. The result is unit of work equal Nm or joules, or we can write as G. So, what do you learn today? Yes, Cherry? Very good. Okay? Now, let's have a last but not the least activity. Guess which picture is work is done, write check if it is the work is done, and write X if the work is not done. So you have a few minutes to answer. Okay, time is up. Now, as you can see in the first picture, what is the answer? It is work is done or the work is not done? Yes, very good. The work is done because she is pulling a toy. Okay. The second picture is, yes, very good. The work is done because he is carrying a box from to another place. Okay, very good. This is check. This, a woman carrying a bag, but she is standing only. What is the answer? Yes, very good. We put X because the work is not done. There is no displacement from the another places. Okay? The second one, or the last one. Okay, yes. The work is not done. Why? Because there is no force or motion in this picture. Because there is no person or someone pushes the mango to fall in the ground. Okay, very good. Okay, class. Now I know and I see that you already understand our class this morning. You can take your recess. God bless. That's all. Thank you. Goodbye, class.